Chihali. So today I want to talk about artificial hand technology, including the prosthetic hand as well as assistive robotic hands for blind people. I think the market size is pretty big. There are more than 2.5 million prosthetic users in the United States and more than 250 million people who live in blind or visually impaired. So as an example of a gold standard system for each category, here on your left side, you are watching the first human being who are attached the mind-controlled prosthetic arms with a complete range of motion. On your right side, you are watching the image of assistive robotic named Baxter's. This is for navigation assistance for blind people, especially in airport or bus stations. Obviously, these technologies are very important and valuable technology for those people who need help. However, there's one big challenge in this technology. Actually, these artificial hands are strongly related to the social interactions, such as handshaking, gentle stroke pad, or even high five. Imagine that you would not like those cold or rigid feeling when you are holding your baby, right? So it's time to think about the psychological well-being for those people. So to improve these social interactions of those artificial hands, these are some example of existing solution by using human-like artificial skins to provide a human-like appearance as well as softness. However, this is just structure, non-functional structure. And you can also block the surface of your artificial hand where most of the sensing elements are located, which is not good. So alternatively, researchers developed this electronic skin. Basically, they fabricate flexible sensors and then they just wrap around these prosthetic hands, resulting in very poor mechanical and electrical coupling between them. So to overcome these limitations, our innovation is to develop a novel human-like electronic glove. And these are the definitions. The e-glove is a thin human-like electronic skin that is directly built on commercially available glove. This is the key innovating part. So here we are trying to use the commercially available glove as a substrate for stretchable sensors. So we have very unique technique that can build functional sensors on top of any kind of glove to detect pressure, hydration, temperature, etc. In addition to that, you can also incorporate these human-like encapsulation layers to provide the human-like appearance, softness, as well as the warmth. You can, just by simply including the thermal actuators over the surface to maintain the surface at the body temperature all the time or in on-demand manner. This is our team. So I'm an engineer, so I designed the device of e-glove system. I collaborate with Dr. Byung-Chul Min in EC department at Purdue. He's actually one of the main inventors for this Baxter robot, which is the assistive robotic hand. So he can validate the utility of our e-glove system for robotic arms application. We also create collaboration with Dr. James DeWeese, who is a director of Prosthetic Center of Indiana. So he's the prosthetic expert, so he can provide very valuable feedback for us to optimize our e-glove systems. And now we are looking for business partnerships. Thank you for your attention.